Hello everyone. Today we're going to begin Unit 5, which is called Chemical Nomenclature. That's just a fancy term for saying that we're going to be naming and writing formulas for chemical compounds. Let's get started. You may recall from our unit on bonding that ionic compounds are composed of positive and negatively charged ions. Now, in order to form a neutral compound, we might have to change the number of positive and negative ions that we have. Now, in the case of simple binary compounds, which is what we'll be learning today, we have to pay attention to those charges. So in our first example, we have the compound sodium chloride. Sodium is in group 1 on the periodic table, so it will form a positive 1 charge. Chloride is in group 17 on the periodic table, so it will form an ion with a negative 1 charge. So the compound sodium chloride is simply the combination of positive 1 and negative 1 charges. In our second example, we have the compound sodium sulfide. In this case, sodium still maintains its positive 1 charge because it's found in group 1, but sulfide has a negative 2 charge because it's found in group 16. Now, in order to get a neutral compound, I'll need 2 copies of my sodium ion in order to balance out the negative 2 charge on my sulfide ion. In some cases, you may need to find out what's called the least common multiple in order to get the charges to balance out. So in the case of our third example, calcium phosphide, we have calcium ions which are in group 2 holding a positive 2 charge, and phosphide ions which are in group 15 and have a negative 3 charge. In order to get these to balance out, we need to find the least common multiple. So the least common multiple of 2 and 3 is 6. By that, I mean if we take 3 copies of calcium with a positive 2 charge, we'll get to a positive 6 charge. If we take 2 copies of phosphide with its negative 3 charge, we'll get a negative 6 charge. That'll allow the positive 6 of calcium ions and the negative 6 of phosphide ions to cancel each other out. Let's take a look at what this looks like. As you can see, the total charge is 0. Positive 6 due to 3 calcium ions is canceled out by the negative 6 due to 2 phosphide ions. Today we're going to go over the instructions for naming and writing formulas for simple binary compounds. These are compounds that have fixed charges. That means we'll simply look at what column they are in on the periodic table in order to figure out what their charge is. Let's take a look. It says that the first thing that we should do is write the full name of the first element, which is known as the cation. The second thing that we should do is write the second element, the anion, but we're going to change the ending on the anion to an IDE ending, which is going to indicate for us an element off of the periodic table. So looking at our first example, we have Na, which we recognize as sodium. And we have Cl, which is chlorine. However, in this case, according to the instructions, we're going to change the ending to an IDE ending. So we'll wind up with chloride. In our second example, we have the element calcium. And the element bromine. Bromine's ending will change to bromide. Some of you might be asking, how come we didn't have to do anything for this 2 down here? And that's because these elements have fixed charges. When one scientist says to another scientist, here's some calcium bromide, they each know that calcium bromide, because calcium has a positive 2 charge, that they'll need 2 bromine ions in order to balance out that charge. It's an understood premise. Let's take a look at some examples. So these examples are the first 10 examples on your homework assignment. We're going to work through these together, and then I'd like you to finish the remaining examples on your own. So, in the case of the first one, we have the element magnesium, going to write out the full name of the first element. We're going to change the ending on the second element to an IDE ending. So in this case, that will be sulfide. In the case of number 2, we have potassium. The ending on the second element, bromine, is going to change to bromide. The third example, notice we're not going to do anything about these subscripts down here. Name of the first element is barium. Name of the second element is nitride. The fourth example, the name of the first element is aluminum, full name. The name of the second element is oxide. In the case of number 5, the name of the first element is sodium. The name of the second element is iodine, but we're going to change it to iodide. In example number 6, we have strontium. Our second element is fluorine, but we're going to change that ending to fluoride. Number 7, name of the first element, lithium. Name of the second element, sulfur, but we're changing the ending to sulfide. Number 8, we have radium and chlorine. We're going to change the ending on chlorine to chloride. Number 9, we have calcium. We're going to change the ending on oxygen to oxide. In our final example that we're doing together, we have the element aluminum. And the second element is phosphorus, but we're going to change the ending to phosphide. So, to begin, please finish off the remaining examples for the simple binary formula to name. In our next part, we are going to learn how to write formulas for chemical compounds based on the charges of the ions that make them up. So first thing, it's important to review which group on the periodic table is associated with what charge. So hopefully you remember from chemical bonding in the periodic table unit that group 1 on the periodic table elements have a positive 1 charge, group 2, positive 2 charge, group 13 on the periodic table is going to have a positive 3 charge. Now, group 14 is kind of that turning point where you could have a positive 4 or a negative 4. We're not going to see a lot of group 14 elements in our ionic bonding. So I'm going to skip over to group 15. Here we're going to see a negative 3 charge. Group 16, we're going to see a negative 2 charge. In group 17, we'll see a negative 1 charge. Group 18 elements are only going to participate in very limited covalent bonding, so we won't see group 18 elements in any of our ionic bond examples. Now, let's take a look at the instructions for writing out the chemical formula given the name. So the first part says to identify the charge on the cation, which is the positive charged one, and the anion. My suggestion to you would be to write out those on the line. Second, if the charges are the same, write the element symbols, cation first, anion second, and drop the charges, including the positive and negative signs. None of our final answers should have any charges with them. Third, in the case where they're not the same, we're going to identify the least common multiple, and we're going to decide how many cations and how many anions are necessary to reach that least common multiple. That's going to give us our neutral compound. So let's take a look at our first example. We have rubidium. Rubidium is in group 1, so rubidium is going to have a positive 1 charge. We have iodide. Iodide's in group 17 on the periodic table. That's going to have a -1 charge. So in this case, the +1 and the -1 charges are going to drop out, and our final answer is just going to be RBI. Let's take a look at our second example. Here we have magnesium. On the periodic table, magnesium is in group 2, meaning it has a +2 charge. And we have phosphide. Phosphide is in group 15 on the periodic table, meaning we have a -3 charge. In this case, we need to find the least common multiple. Well, in this case, with +2 and -3, the least common multiple is going to be 6. So ask yourself, how many magnesiums do I need in order to get to 6? Well, if they're +2 each, I'll need 3 copies of magnesium. So I'm going to put a little 3 down here at the bottom. And in order to get to 6 using phosphide, I'm going to need 2 copies. So phosphide is going to have a 2- at the bottom. Now, just showing you why this works out this way, imagine that I wrote out these ions. So magnesium, remember, has a 2+ charge, and I need 3 copies of it. Phosphide, which has a -3 charge, I wrote down that I need 2 copies of it. The reason this works out is because the total charges balance out. 3 magnesiums give me a total charge of +6. 2 phosphides give me a total charge of -6, meaning we formed a neutral compound. It is very important that the number of positive ions and the number of negative ions, when you add up their total charge, should balance each other out. Okay, let's take a look at some examples. In each of the examples that we're about to look at, the first thing that I'm going to do is identify the group on the periodic table and the charge associated with that group for both the cation and the anion. So for the first one, we have lithium sulfide. Lithium is in group 1 on the periodic table, so it has a +1 charge. Sulfide is in group 16 on the periodic table, so it has a -2 charge. In this case, in order to balance out the +1 and -2, I'll need 2 lithiums. So I write that by putting a subscript of 2 here in order to balance out the sulfide charge. So 2 copies of the thing that's +1 will balance out the -2 charge on sulfide. Let's take a look at number 2. We have potassium bromide. Potassium is +1. Bromide is -1. This time, because they are the same, they will cancel each other out, meaning I need just 1 copy of each. So I don't have to write any subscripts in this example. Let's look at the next one, cesium iodide. Same thing here. Cesium is in group 1. Iodine is in group 17. So we have CSI. In my fourth example, I have calcium. Calcium has a +2 charge because it's found in group 2 on the periodic table. Phosphide, which is found in group 15 on the periodic table, has a -3 charge. Here's a case where I need to find my least common multiple. So 2 and 3 is going to be 6. That means I'll need 3 copies of calcium, and I'll need 2 copies of phosphide in order to get to that equal point where they'll cancel each other out. Okay, in example 5, we have sodium, which is in group 1, so it's +1. Fluorine, or fluoride, which is in group 17, so it's -1. +1, -1 cancel each other out. So we have NaF. In the 6th example, I have strontium. Strontium is in group 2 on the periodic table, so it has a +2 charge. Oxygen, which is in group 16 on the periodic table, has a -2 charge. Again, here we have +2, -2, cancel each other out. So we're left with just SRO. Next, beryllium, group 2 on the periodic table. So we have Be with a +2 charge. Sulfide, that's in group 16 on the periodic table, so a -2 charge. +2, -2 cancel each other out, so we're left with just BeS. Number 8, magnesium, that's in group 2 on the periodic table. Bromine, which is in group 17 on the periodic table, has a -1 charge. So in order to get a neutral compound, I'm going to need 2 copies of the bromine, which is -1, in order to balance out the magnesium's +2. In our 9th example, we have lithium, that's in group 1 on the periodic table, so it's a +1. We have oxygen, oxygen is on group 16 on the periodic table, so we have a -2 charge. In order to balance out these 2 charges, we're going to need 2 copies of our lithium. So Li2O. Finally, in example number 10, we have strontium that has a +2 charge. It's in group 2 on the periodic table. We have chlorine that's in group 17 on the periodic table. So that's a -1 charge. We'll need 2 copies of the chlorine, -1, in order to balance out the +2 charge. A reminder, group 1 on the periodic table, 1+, group 2, 2+, or +2, doesn't matter to me. Group 13 on the periodic table is 3+. Group 14 is kind of +4 or -4. We're not going to use those, but let's go on to group 15, 3-, group 16, 2-, group 17, 1-. Please finish up the rest of these examples. When you're all done with the simple binary compound assignment, please submit it on Schoology. Thank you, and please let me know if you have any questions. Have a great week.